Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2019. This question was from the topic of motional EMF and this was a fairly simple question. I believe most of the students in India who went on to qualify JEE Advanced would have done this question without much of the problems. This was based upon multiple MCQ, that means multiple choice correct question. So here we have a parabolic wire which is of the shape y equals to x square and it is moving with the velocity constant v naught I cap in presence of a magnetic field whose value has been given to us. V naught L are positive constants and we have to comment upon the value of the EMF developed across the wire because of the motional EMF for the different values of beta, and there are certain other things that are being asked in the question. We will talk about them as we solve this. The There was also a figure given in the question. This figure was given in the actual question of IIT. So you can see this is the wire and the top y coordinate of the wire is L and the x coordinate is root L, which satisfies the equation y equals to x square. Now, if you remember, if you can recall the motional EMF, if you take a small amount of length, let us say this part, okay, this part of the length. So if you call EMF d phi, then it will be dl, and velocity and magnetic field and all this will be mutually perpendicular, because if you recall the formula dl dot v cross b, so the it is scalar triple product. So basically all these quantities will the mutually perpendicular components of all these quantities will come into picture. So if you see, velocity is already in the x-axis, magnetic field is towards us, and hence the length should be along the y-axis. So in reality, if you consider this length, then the y projection, which is this part of this wire is actually going to contribute in the induced EMF. There will be no induced EMF because of this length along the x, right? So if we assume that this part is lying at the location of y, that means you can say that the y coordinate of this wire is y, because this is a very small part. So we can call that we can say that it is lying at the location y, and this is of length dy. Okay, this length is dy. So EMF can be written as d phi equals to dl vb. So dl, now I'm replacing this dl by dy, rather dy. So d phi will become velocity is v naught, magnetic field function was given as b naught into 1 plus y by L whole to the power beta into dy, right? So if we integrate this whole function, so L we can integrate y from 0 to L. So this will become v naught b naught, 1 dy will become 1 dy will become y, okay, and this y by L to the L is constant, it will come out of integration sign, y to the power beta, y to the power beta will become y to the power beta plus 1 by beta plus 1, right? And in this whole thing we are going to put the limit 0 say L. Okay, the phi ka value that we are getting is v naught b naught. If you put L, so this becomes L plus L to the power beta plus 1 by L to the power beta. So that will become L, in my opinion, upon beta plus 1, right? And if you put 0, then anyway it is going to become 0. So this becomes v naught b naught L, and this will become beta plus 1 plus 1. So beta plus 2 divided by beta plus 1. This is what we get. This is the induced EMF. Also, let's talk about the direction of the induced EMF. That means which point or which pole will be at the higher polarity. That means whether the bottom of the parabola will be at the higher polarity or the top. So it's very easy to find the higher polarity. Always the higher polarity is in the direction of v cross b, velocity cross field. So velocity is in the right direction and magnetic field is coming towards us. So v cross b is pointing downwards. That means this point will be at the bottom of the parabola, will be at the higher polarity, and this will be at the lower polarity. Okay, so L v naught b naught divided by beta plus 2 by beta plus 1. Now if you go back to the options for beta equals to 2, so if you put beta equals to 2, so this becomes 4 by 3, and hence option A is right, absolutely right. Delta phi remains same if the parabolic wire is replaced by a straight wire of y equals to x initially of length root 12. So if you replace this parabolic wire by a straight line and this length is root 2l, so of course we can say that this is 45 degrees. So this will also be L and this will also be L. Now if you see again for this wire, if you consider a y like a small element over here, so it's y coordinate. For this y coordinate for this small length, I'm going to make the same function. It's just that magnetic field will be same, dy will be same, v naught will be same. I'm going to create exactly same function, and when I will integrate from 0 say L, so I'm going to get the same result. That means I'm going to perform the same map. If you can look over here, if you take this wire, this small segment, and you write the potential EMF function over here, so basically 0 say L, if you're going to integrate, you're going to get the same thing, and hence your answer will remain the same. So this option is also right. Delta phi equals to half B naught V naught L for beta equals to 0. So if you put beta equals to 0, you are going to get 2 B naught V naught L. So option C is wrong. Beta equals to 0, by the way, was a very simple case. If you put beta equals to 0 here, so this becomes 1 plus 1, 2. 2 B naught is the magnetic field. And you can see that magnetic field, if it is 2 B naught, then anyway, you could have replaced this by a, like this wires, like, constant magnetic field, you can replace this any shape wire by a straight, like, this type of wire, like this. And then you take y projection, so it would have become L into 2b naught into v naught, which is the result that we get. So anyway, you could have gotten the result for beta equals to 0 straight away. If you see this option, delta phi is proportional to length of the wire projected on the y-axis. So of course we can see that delta phi, which is the EMF induced, is actually proportional to the L, because this length, the length of the projection on the y-axis is nothing but the L, and hence option D is also right. So as you can see, it was a simple procedural question based upon the induced EMF, and most of the students would have done this without any difficulty. That's all. Thank you.